Okay, sample and population means part 1. So we're clarifying, if you're watching this video, what you should have learned already, okay, prior learning, and then we're going to compare and contrast the concepts and definitions that you may have seen in your prior learning, and then contrasting it with the current learning, which starts with this video. Okay, again we're going to look at sample means and population means. Okay, and if you're watching this video, you should have already studied probability distribution functions. So probability it's long words. Probability distribution functions for continuous random variables. Now if you don't know what that means, you need to go to a different video in a different playlist, perhaps a Math Methods playlist, and I'll see if I can put a link on the screen in this video that will direct you to such a resource that will help you out. But if you are okay with that, we'll continue on. And so we might be talking about, with these probability distribution functions, we might be talking about PDFs, probability density functions, normal distributions. Should know what that means if you're watching this video, and exponential probability distribution. So the exponential probability distribution, which often looks at things like queuing and so on, okay, or the time it takes for a component to fail, but that should be known. Furthermore, you should already know what these terms mean: population, the whole group of interest, the relevant group, the entire group, the sample, especially chosen randomly, population parameter, should know what that means, sample statistic, again if you don't know what these mean, go back to the appropriate video. These are key things, and perhaps with sample statistics you've seen previously previous work, you've seen this thing called p hat, which is the sample proportion. That's in previous work. We're going to contrast with what we're doing in this body of work, however, sample proportion, and you might have seen previously little p, which is the population proportion. In this unit and in this sequence of videos, we're going to look at something else instead of the sample proportion. We're going to look at what's called the sample mean. Sample mean. Okay, so the sample mean, or lower x bar, the sample mean is what we're going to look at, and that's the statistic that we're focusing on instead of sample proportion. Okay, and instead of the population proportion, we're going to be looking at the population mean. That's the thing we're trying to estimate. That's the parameter we're trying to estimate, the population parameter. Okay, the sample mean, which is the symbol mu, which you probably have seen before. Now please note at this stage, you've probably seen this idea for all the distributions you've studied. If the sample mean is lower x bar, it's random, the associated random variable is uppercase x bar, so that's the associated or the relevant random variable. because lower X bar is the statistic, which is an estimate of the population parameter. Uppercase X bar is the associated random variable. So X bar is the associated random variable. It's associated with the sample mean statistic. Okay. So previously we would look at proportions of a sample with a characteristic of interest to us. Okay, and this is what we've done previously if you're watching the right video, and hence we would use it to estimate, or hopefully it would be a good estimate of the population proportion, the population parameter, which is population proportion, with that same characteristic. Now that can be done when we talk about estimates. That can be a point estimate, which is like a one-off, and fingers crossed hopefully that's a good one, point estimate. And in the past you would have seen interval estimates, like confidence interval, for example. So now, to compare and contrast, now looking at the sample mean of a certain measurable, okay, so that might be continuous data, a certain measurable characteristic of interest within a population. Okay, so it's not so much now whether it's got a characteristic or not. It's a certain quality which is measurable within a population. Okay, that's what we're looking for, the sample mean, the average, the mean of that, which is usually continuous data, and it's a characteristic within a population. And so it's the same thing. We use statistic X, so the sample mean, as an estimate of the population mean for that characteristic mu. So it was whether or not, with the case of p hat and p, it was back then it was whether or not something's got it or not, and it's the proportion, whether it's the proportion in a sample or the proportion in the population we're talking about. We're talking about the proportion, yes or no, does it have it, does it not have that characteristic. Whereas now we're measuring an aspect related to a characteristic of interest, maybe mass, for example, or the number of hours. Okay, we're looking at that, and we're looking at the mean of the sample, and we're hoping that can be an estimate, reliable estimate of the population, one that we can have confidence in. Okay, so that's a conceptual beginning of where we're headed now, and hopefully if you're watching these videos in the right sequence, this is making sense on what is similar but what is also going to be different in this part of the study